everyone, welcome to our online video tutorial series. And dear students, today we will discuss about class 11th topic sets part 2. Let's start. So students, till now in the previous video we learned about definition of a set, elements of a set and representation of a set in various form, that is the Cartesian form and the set builder form. Now in this video we will learn about empty set, cardinal number of a set, Singleton set, finite and infinite set, equivalent set and the equal sets. And we will also solve some problems based on the NCERT textbook. So let's start. So first we will discuss empty set. Empty set, as its name suggests, means a set which is empty, means having no element. It is also known as null set, void set. So let's define it. The set which is empty, that means there is no elements in the set. And the set is represented by this Greek alphabet phi or this empty braces, curly braces, that empty we had written there. So these represents the set. Here I taken an example of set P, where P consists of the elements X. What is an X? X is a leap year between 1904 and 1908. See how many years are in between this 1904 and 1908. So 1905, 1906, 1907, and none of them is a leap year because none of them is divisible by 4. So they are not divisible by 4. So no leap year lies between 1904 to 1908. So it's an example of the empty set. So another example, let x is a multiple of 5 between 6 to 9. So between 6 to 9, if we see that, numbers will be 7 and 8. And both are not the multiple of 5. So no element in between this. So when I represent this Q as an empty set, I should write it like this, either empty braces or phi. But in case if I write this one, so it is not representing an empty set. This is a wrong example. The reason, this set is having one element named phi. Okay, so this is not an empty set. So this set is having one element named phi. So either empty braces or this symbol, not both of them altogether. So now we have to solve some examples. Which of the following are examples of the null set? The set of odd natural numbers divisible by 2. Dear students, as you know that odd natural numbers are 1, 3, 5, so on. But none of them is divisible by 2. So yes, it's an example of empty set. Set of even prime numbers. So even prime number is 2. So it is having one element, so it is not an example of empty set because it is having one element. So it's not an example of null set or empty set. A number which is x is a natural number where x is less than 5 and x is more than 7. So the word is here and, means we have to select a natural number such that it should be less than 5, simultaneously it should be more than 7, which is not possible, more than 7. So it's an example of empty set. Yes. Y is a common point to any two parallel lines. So any two parallel line will not have any common point. So yes, this is an example of empty set. So I should say yes. So what is a cardinal number? As you know that set is a collection of elements. Okay, so the number of elements present in a set is known as cardinal number. So what is that cardinal number? Cardinal number is the number of elements present in a set. For an example, the set A, E, I, O and U is having 5 elements. So I will write down that cardinal number of A will be 5. So this is the way to represent that number of elements in A, or you can read it as cardinal number of A will be equal to 5. So what is the cardinal number of an empty set? As we discussed earlier, empty set is having no element. So cardinal number of empty set will be 0. No elements. See beta, when I am talking about cardinal number, so it's a number and this is a set. Set may not have any element. So how many elements? Then we'll say that it is 0 elements. So number of elements will be 0. So it's a number. So cardinal number of an empty set will be 0. Singleton set. What is a singleton set? As the name says, singleton means a set having only one element, single element. The set contains only one element, then it is called singleton set. For an example, X is an even prime number. As we discussed earlier, even prime number is 2. So only one element is there. So it's an example of singleton set. Y is a whole number which is not a natural number. As you know that whole number starts from 0, 1, 2, 3, so on. And but if I see that natural numbers are starting from 1. So if we exclude all these numbers, what number we will have? 0. So only one element here, 0. Yes, it's an example of singleton set. What is a finite set? In this set, the number of elements is finite. Finite set means number of elements is finite. That means cardinal number is finite. So how we'll define it? If a set contains no element or a definite number of elements, then it is called finite set. So focus on this. No element means empty set is a finite set. So many times they may ask in an objective type question, empty set is an example of finite set because its cardinal number is 0. So we can define it. So it's a empty set. And other, those cardinal number is non-zero. That means they are non-zero finite set. So some examples of the finite set are X is a month in a year. So we have only 12 months in a year. So that's countable. So number of elements in A will be 12. So we will say that yes, it's a finite set. X is the 0 of the polynomial and this is the polynomial given here. X raised to power 4 minus 6x square plus x plus 2. So as you know, beta, in class 10th we read that how many maximum zeros this polynomial can have. This polynomial can have maximum 4 zeros. So we are not going to solve it, but just by looking at this we can say that maximum it will have 4 zeros. So it may be 0, 1, 2, 3 or 4. Cardinal number of this set will be either 0, 1, 2, 3, 4, depends on the value of x. But in any case it will be a finite number. So yes, it is an example of finite set. So just contrary to the finite set, it will have infinite elements. If a given set is not finite, then it will be an infinite set. That means if we cannot write the cardinal number of a set, then it is to be declared as infinite set. Let's see an example. X is a natural number. So as you know that there are infinite natural numbers, so A is an infinite set. If I keep on writing the natural numbers 1, 2, 3, 4, 5, I can keep on writing because there is so greatest natural number does not exist. So it's an example of infinite set. Which of the following sets are finite or infinite? So set of month of years, as we discussed earlier, its cardinal number is finite. It's a 12. So yes, it's an example of finite set. Next, 1, 2, 3, dot, dot, dot. That means it's a infinite set. Next is 1, 2, 3, so on up to 100. So it's a fixed number series. Natural numbers up to 100. Yes, it's a finite set. Set of positive integers greater than 100. So greater than 100, there are infinite positive integers. So we will say that yes, it's an example of infinite set. Set of prime numbers less than 99. So we can calculate the set of prime numbers less than 99. Yes, it is a example of finite set. Next is state whether each of the following set is a finite or infinite. The set of lines which are parallel to x-axis. So if I draw x-axis and y-axis, so how many lines I can draw parallel to x-axis? I can draw infinite lines parallel to x-axis. Correct, na? So this is an example of infinite set. So the negative side of y-axis. So it's an infinite set. Next is the set of letters of English alphabet. Cardinal number is fixed, 26. So it's an example of finite set. The set of numbers which are multiple of 5. So multiple of 5s are infinite. So I should say that it's an example of infinite set. So our next is equivalent set. What is equivalent set? Let's understand with an example. So here I have taken two sets, set A and B, where set A is having the elements A, B and C, and set B is having the elements X, Y, and Z. And as you can see from animation that both the sets have equal cardinal number. Number wise they are equal, even their elements are not similar. So such an example of set is known as the equivalent set. Finite set A and B are equivalent only when numbers of A and B are equal. So in simple words, I can say that number of elements in A is equal to number of elements in B. Our next concept is equal sets. So earlier we discussed about the equivalent set. Equivalent means number of elements were equal. And what will happen in equal sets? Two sets are said to be equal sets if every element of one set is in the other set and vice versa. So not only elements of one set exist in the second one, but all the elements of second also exist in the first one. So let's take an example. I have taken set A and B. So having elements, set A is having elements X, Y, Z. So you can see that all the elements of A lies in B and all the elements of B are in A. Let's understand with the help of an animation. So this A overlaps B. That means exactly same. Not only number wise but elements wise also. So in mathematically, in other words, I can say if X belongs to A implies that X belongs to B. That means all the elements of A also belongs to B and all the elements of B belongs to A. Then we'll say that the sets are equal. So now we have to tell in this example whether following state whether they are equal or not. So set A and B. Just see. It is having four elements. This is also having four elements. It's having A. It is having A. B, B, C and D. All four elements are available here. And all the elements of B are in A and A are in B. Vice versa. Okay. So I can say that in this case A is equal to B. So dear students, in set theory, it is not necessary that two sets are equal, then they must be written in the same order. Order doesn't matter here. In the second example, I can see that 4 is there, 8, yes, but I cannot find this 12 here. So I'll say that A is not equal to B, even though they are the equivalent set. So here one set is given in the roster form and other part is given in the set builder form. First, let's convert this part in the roster form. So what it says, B consists of the elements X, where X is an even integer and X is less than equal to 10. So what are the even integers which are less than 10? 2, 4, 6, 8 and 10. Now check that whether A or B are equal or not. Yes, A and B are equal sets. X is a multiple of 10. So this time left hand side is given the property method. So multiple of 10 will be 10, 20, 30, so on. Now check that whether A and B are equal or not. What is B? 10, 15. 15 is not a part of this set. So A is not equal to B. That's all about today's video. Hope you enjoyed this. Thank you very much.